Okay, so question number 4 is to draw the Lewis structure of PCl3. Okay, so let's do all the different steps of the question in order. So A, what is the total number of electron pairs in this Lewis structure? So let's find... Well, first let's draw the Lewis structure before all of this. Oops. And then this will help us answer all of the questions. So first, let's find the total number of valence electrons. In the case of phosphorus, there are 5 valence electrons. In the case of chlorine, there are 7. And since there are 3 chlorine atoms, we multiply this by 3. And if we were to add these up, we get a total of 26 valence electrons. So now let's draw the PCl3 Lewis structure. So I'll have phosphorus in the middle, and then I'll have my 3 chlorine atoms symmetrically arranged. And at this step, I like to draw in all of the valence electrons on my chlorine atoms. Okay, so if I count out how many electrons I've drawn so far, each bond contains 2 bonding electrons. So we have 3 bonds and 6 bonding electrons. And then each chlorine atom has 6 valence electrons. So I've drawn a total of 24 in this structure. So since my total valence electrons is 26, I need 2 more electrons to add. So they are going to go on my central phosphorus atom in the form of a lone pair. So now I have my 26 electrons, and all of my atoms have a full octet. So everything is good. So now let's try to answer the 4 parts of the question. What is the total number of electron pairs in this Lewis structure? So when we say electron pairs, this refers to the number of electron pairs that are attached to our phosphorus. So if we count out, it has 1 lone pair of electrons and 3 bonding pairs of electrons, then we have a total of 4 electron pairs. Okay, part B. What is the number of non-bonding electron pairs on the central atom? So this is our lone pair, and there's only 1. So I'm going to write 1 non-bonding electron pair. And for C, what is the geometry of the electron pairs around the central atom? So we have 1 lone pair, as we have established. And if we count out how many bonded atoms we have 3 bonded atoms. So at this point of the question is when we would use a Vesper theory chart to help us answer the remaining questions. So I like to find a table that has everything. So if we look and see how many bonded atoms we have 3, and we have 1 lone pair. So this corresponds to a trigonal pyramid molecular shape, and a tetrahedral electron geometry. So the question asks, what is the geometry of the electron pairs around the central molecule? So this is the same as electron geometry. So we have tetrahedral electron geometry. So for D, tetrahedral electron geometry. And then for part E, what is the geometry of the molecule? This corresponds to this column, which is molecular shape. And you can see that it is trigonal pyramid. So the difference between electron geometry and molecular shape is that the electron geometry corresponds to all of the electron pairs on the central atom. So in our case, all the electron pairs, this was part A, so the lone pair and also all the bonded electrons. If we were to have a 3D model, then this has a tetrahedral geometry. But in the case of a molecular shape, this only counts the atoms, so it doesn't count the lone pairs. So if we were to also have a 3D shape of the molecule, but we neglect the lone pairs, then you'll see that we're left with a trigonal pyramid molecular shape. So this is why when we have 0 lone pairs, then the molecular shape and the electron geometry would be the same. So if we look at the table, when there's 0 lone pairs, for the first 2 rows, they're both linear. When you have 0 lone pairs on 4 bonded atoms, you have tetrahedral, and it's just the same for both. So this is the difference between the two. So now let's see what the junior tutor said. The total number of electron pairs is 4. The number of non-bonding electron pairs on the central atom is 1. The geometry of electron pairs around the central atom is trigonal pyramid. So I think they meant for this to be in part D. Geometry of the molecule is bent. So we know that it's not bent, because if it were bent, this is for when we have 2 atoms and 1 lone pair, or if we have 2 atoms and 2 lone pairs. But since we have 1 lone pair and 3 atoms, then we know that we have a trigonal pyramid molecular shape. So I'm just going to fix this. Oh my gosh, I can't spell. Can't spell. And okay, so I said the Lewis structure and parts A and B are correct. However, since there are 3 bonded atoms and 1 lone pair on the central atom, we have a tetrahedral electron geometry and a trigonal pyramid molecular shape.